Okay, so let's start this up. This is the shunt motor. The shunt motor has, as we know, poor starting torque, but very good speed regulation. So that's what you're going to notice with this, and then we'll compare that, right? Everything is in comparison to something else. That's what they're saying in comparison to the series motor, especially. You're going to see that, those differences. All right, so start it up slowly, bring it up to speed. And the voltage that we wanted is 125 volts DC. Okay, so I got it up to there. One of the things I want you to notice too, I'll just slow it down again. Everything's working. Is this DC ammeter here? Just watch what happens when I turn it up. In fact, I'll just slow this down, the brake. If I turn this up, watch what happens with the meter. And then watch it actually move back. Okay, why is it doing that? The counter EMF? Yep. Yeah, so at the startup, there's no counter EMF. And then as the motor starts to rotate and starts cutting lines of flux, the armature does, then it produces counter EMF in the armature. And that's why the needle does that. And so again, it would same thing, as soon as you turn it up, as soon as you that. It's just going to keep doing that. It's inrush current, counter EMF. Okay, so 125 right there. This crony brake is a little bit off because it's already reading 1 Newton meter here. Okay. But it's 1454 for the current or for the RPM at 0 load and about 1.5. So I'll use a different. 4 and 1.5 for the current. Okay, so then I'm going to turn it up to 2 Newton meters. It's already at 1, so that's what we're using as our. So it's going to go to 3. There's 3. The instructions say to make sure that the voltage stays the same, so I drop about half a volt. So I'll just turn it up a little bit here, just to make sure that the voltage stays consistent. Reacts. Okay, go to the next one. And the RPMs were 1447. Last one. Okay, so that's all the readings from that motor. So we can see that we only dropped about 20 RPM from no load to, well, 10 Newton meters. Whether that's full load or not, I don't know. But it's significantly changed the current here, right, from 1.5 all the way up to 8.1. So probably we're pretty close to being fully loaded at that point. So what I'm going to do is I'm going to shut the motor off. Let the brake slow it right down. And then we're just going to take a look at the last part of this experiment, which is to start it under load. Okay. Yesterday when I did this, there's a pin in the back that holds this little rod here to the weight at the back, the counterweight, and just snapped it. So I replaced it. So let's try her again and see what happens. Pop, pop. Okay, overloaded. Yeah. So it doesn't like that. It can't. What's that use? These, I don't, 20 amps. And they're a little hot right now, and the wires are quite warm.
Nice.